squeezing out that efficiency is something you can do later as long as you understand where those costs are and kind of where you lie on the curve, right? So what I'm saying is it's not important to do the work to optimize upfront, but you want to understand how far along that curve are you and what kind of gains you think you could get later, right? Because it's just like, oh, well, if a request right now, requires a Ruby process that's taking 100 megs of RAM to service, and then you kind of look at, well, here's how many simultaneous requests I can serve based on a machine with X amount of RAM. But you know that if you were to convert from Ruby to Node.js or something like that to service those particular requests, you might be able to drop that RAM requirement down to 10% of what it was. You don't necessarily need to do the work right now, right? You just need to know that you have in your back pocket the ability to do that so that if it becomes a big cost center that you can do that. Yeah.
Is that based on your own infrastructure or renting infrastructure?
Well, sorry, I didn't hear the second part.
Is that based on having your own infrastructure in place, or is that it applies to both? Like, for example, going to
if it was cloud.
AWS,
Yeah. Either way.
Go to like an AWS or similar, like Open Rack, I think, or Rackspace.
Sure, Rackspace, yeah.
Then how do you keep track of costs, especially when you're prototyping? Is like you don't want to spawn like bazillions of processes.
Right.
So how do you like all of a sudden you get a bill?
Sure. Yeah, so Rackspace I'm a little less familiar with in terms of how quickly they make cost data available. Amazon is really good. In terms of Amazon, you can actually see, you can download at any time. Basically, the cost data, I think it runs slightly behind, but it runs like an hour behind or something like that. I mean, it's like super up to date in terms of what costs you've incurred on Amazon. So you can do things like run a load simulation, for an hour or whatever, and then see what your costs are associated with that. Also, frankly, in most cases, you don't have auto scaling turned on, and we'll talk about some services where that is a little different. But in the case of like a standard Rackspace Cloud implementation or a standard AWS EC2 implementation, your costs are actually fixed. I mean, you're just like selecting how many servers you want. Yes, you could turn on auto scaling, but one of the easy ways to understand your cost is, you fire up one app server or and one database server and whatever. You start running load against it, and you see what percentage of those servers you're taking up. You have a fixed cost per month associated with each one of those servers, so it becomes pretty easy to calculate out, per user or per request what your cost is going to be. Sure.
Do you think it's important as an early stage priority to get metrics in place other than cost?
Yeah, for sure. And there's a whole section on instrumentation and metrics that we will cover in a little bit. But yeah, those are good questions on cost for sure. So I do think getting a handle on it in some of the ways we were just talking about, like running those simulations is good. And then you can be off by some. You need to understand what your business model is, which is probably vastly different from company to company for you guys. And how much this matters, right? I mean, that's really what it comes down to is like, how much time do you want to spend modeling this out and tweaking it and trying to understand what the roadmap is to less cost is going to be a function of, well, even if you're doing something really inefficiently, in the case of many of you, it's going to be like, oh, sure, you might be able to do something that literally would have 1/10 of the cost per request, but if you look at how much cost you're incurring, it's like, well, over the lifetime of a user who's paid for your hardware, and maybe you're making a margin on selling the hardware of X amount, like it could be inconsequential what those costs are, but it also could not be, and it really depends on your business and how much we're talking about in terms of using those backend services, right? I mean, there are different. I have seen, and again, I don't have a huge amount of background in hardware devices, but I've certainly seen devices that are heavy users of things like cloud storage and cloud services, because every time you use the device, it might be sending a fair amount of data that it's collecting up into the cloud, and those things tend to be pretty expensive, as opposed to other ones that are just sending very small amounts of data in terms of whatever, just some numerical data associated with something that you used, as opposed to media data, right? I mean, numerical data is super cheap to to store, to move around, et cetera, in this day and age. So those are the sorts of things that, in general, in the back of your mind, how much time you should spend on this up front, it kind of depends on, well, when you think about what you need to be sending through backend services, is it like super heavy data, or is it going to be like, well, every time somebody uses my device, yes, it's going to have a request or two, but the amount of data in that request is like, 500 bytes or a kilobyte or something, which in this day and age, you can have millions of those per day and not run, significant amount of cost, or at least not significant compared to what you guys would hopefully be making on the hardware front at that point. But again, that is different for each of you, and it's a little hard for me to know. I think we can get into particular case studies if you want after the prezo, and be interested in that, or you can contact me directly as well after the prezo if you want to sort of talk through your specific case. This is going to be just more about what we have already covered to some degree. It's important that you have the ability to scale also. So this is different than the efficiency thing that we were talking about and different than time to market. But yes, it is important that you have, I was mentioning the horizontal scalability piece, right? We're all hoping, I'm sure, for each of our companies that it takes off fairly quickly. You obviously can't invest in that up front in terms of buying a bunch of servers. And the great news is we live in a day and age where it's super easy to use cloud services to scale quickly. If you have architected your system such that works, right? I mean, if you just have everything in like one monolithic thing and you have a database that can't be scaled across multiple machines, et cetera, then you're going to get yourself into trouble. So we'll talk a little more about that as well. But the point being, the ability to scale is more important than being efficient up front. And then reliability we haven't touched on. That's another thing to think about. And this, again, for me, when I think about it relative to your businesses, really depends on the type of service you're doing. I mean, everyone wants their service to be up and running 100% of the time, no matter what. You want 9 nines or something, but there are almost no services that run. Even the ones that we think of as being fairly reliable, like Facebook. A reasonable goal for them is like 4 or 5 nines. If you're not familiar with that terminology, it's like what percentage of the time is your service up and running. When you're small, honestly, it's super expensive to architect things to handle the real edge cases. And the real edge cases are things where you have like multiple failures simultaneously, right? You can architect your system to survive, and you probably should. But again, there's this exponential scale to go from an expectation of being up, 2 nines, which would be you're up 99% of the time, to expecting that your service is up 4 nines, which would be 99.99% of the time. It costs exponentially more money to do that. And there's a complexity cost. So it's not just money in terms of, you need to be storing the data in multiple data centers around the world. There's complexity cost that seriously slows down how quickly you can develop things and adds just complexity cost to when you're making changes, adding new features, et cetera. So, in my opinion, certainly before you get away with public launch, you can kind of be in a state, when you're just purely in development, or when you're like in alpha testing and you're just sharing it with, friends and family and other friendlies. You're not going to have to worry too much about reliability at all. Once you get into kind of beta and then you move into like shipping your product, you're still shipping to early adopters. And depending on the type of service, and again, we can talk through some of the things you have, depending on the type of service, there is some amount of tolerance. Certainly we've seen it, Twitter being this great example that we like to use. In terms of just like they went through a time, obviously, of having a lot of downtime, and the fail whale became, everybody's favorite sea creature at that point. But you know what? They're having their IPO, right? They still were successful, even though they had that. People had some tolerance from the downtime, and it actually, even though they had to spend a lot of effort at that point to address those issues, if you stepped back and said, oh, well, they should have, made sure that they had global redundancy across geographically distributed data centers and a bunch of other things earlier in their history, like that's really easy to say. But if you actually start doing the work to implement that. It's a big financial cost and it's a big time cost. So it's trying to pick the reliability level that is appropriate for your service and the stage of your company. So some of that is company stage driven, and some of that is, again, what kind of service are you providing? If you're providing like a 24-hour-a-day security camera that's supposed to be recording things and alerting you when somebody's breaking into your house or whatever, there's probably a fairly high expectation that the service is always up and running. In some of your cases, I think, and we'll touch on this a little more later, you may have services that are just like, well, the device itself has to be working all the time. Of course, you want hardware reliability, but maybe the back-end service is something that is like, just providing a daily report of what's going on, or the device can sort of be synchronizing in the background, and exactly when it synchronizes with the back-end system isn't that important. And if you're in one of those cases, it means like if your back-end system goes down for 10 minutes, it's assuming you've architected your kind of client side correctly, it'll just retry, and 10 minutes later it'll get through, and frankly, almost nobody will notice that it was down for 10 minutes, right? And again, architecting to survive massive problems and unlikely problems is really costly, and big services have to do that. And we all hope that you get to that point someday. But early stage, wouldn't recommend spending a ton of time on, let's say you were at Amazon. It's like, okay, well, within Amazon they have reliability zones, or availability zones. They're separated from other availability zones within a given data center, and then you could choose to be in a completely different data center. So you could architect the system such that you're in multiple data centers. It's a lot of cost and it's a lot of complexity, and there's actually potentially some user impact in terms of latencies and that sort of thing. All right, so that's a bunch of like my assumptions around kind of what's important, or me telling you what I've seen be important. Let's get a little more into actual technologies. So again, sweet spot is a thing that I talked about a little earlier. For language, it's like, don't choose an abandoned language, and also don't choose a language that is just emerging. I think choosing an abandoned one is probably something you're less likely to do. I think choosing one that is new and exciting is a little easier to get attracted to, and not just yourself if you're an engineer or a software engineer at all, but also people who you might hire might have a tendency to want to work in the latest, greatest thing, because it's fun to learn new things, it's fun to play with new toys, everybody likes that. Having said that, just be really cognizant of, if it's too early on that curve, there will be bugs in the language itself, or there'll be bugs in the frameworks associated with those languages more likely, and there'll be just kind of a lack of supporting libraries that you're going to want. Like, one of the things about the day and age that we live in now is, for modern languages that are in the sweet spot, practically anything you need to do, there's already a library to do, right? It's like, you want to do something that has to do with reaching out to the Facebook API or Twitter API, or you want to do something that has to do with a certain database, even if it's a relatively new database, somebody's already written a module that does that. Somebody's already written one that helps you not only do that, but it helps you like manage sharding of it. All these things that would have been projects for yourself to create. There's probably already a module that does it. Workforce and product culture, again, so for some of you, I don't know all of your specific situations, but as you think about language choice, there's like, we can have this abstract conversation of what languages and frameworks are, awesome and in that sweet spot, but that, of course, ignores something that's pretty important, which is, do you already have resources that are super productive in a particular language or framework? Or you have a culture that is oriented towards getting things done in a particular way that matches well with one of these frameworks. People who tend to work in the Microsoft stack versus, say, the Java stack versus, a Ruby or a Python tend to be slightly different in how they approach things, and you need to think about how that fits in with what some of your culture is and what you're trying to do. And again, for me, I think some of that, I don't think there's a single right answer. I think some of that has to do with what is your product, right? There are products that are very like serious, like medical products and things where you probably want it to be like super, super refined and precise way of thinking, versus there may be products that are a little more fast and loose in terms of, hey, let's get new features out there, a little more of the move fast and break things approach, which can be a great approach, assuming you're not breaking somebody's pacemaker or something like that. Right? And that's kind of what I'm talking about when I talk about innovation versus stability of service, right? Yeah.
What's the process you guys go through to find that sweet spot? Like if you're in a new company, where do you go to figure out that criteria?
Yeah, I mean, so for sweet spot, there are a couple different things. I mean, one of them is simply just looking at which languages. There are reports around what languages are most popular, and you can just Google for those. I thought about it including in here, but the problem that I had with it, looking at those numbers actually, is those numbers are kind of overall what languages are most popular. It does show directionality also, so directionality helps a little bit, like which languages are becoming more popular, which languages are becoming less popular. Having said that, that's across all companies of all sizes doing all sorts of things. I haven't seen, but would love to see a report, out there that covers the same thing basically for the startup scene, because what you'll see with the big reports is it actually shows C++ is huge, Java is huge, which you would expect, and then there's some other things that are a little older that rise up there. I mean, C is still huge because there are certainly applications, including hardware, where that makes a lot of sense. But it also shows certain things like Python actually being significantly more popular than Ruby, which is not necessarily the case in like the startup scene. They're both super popular in the startup scene, but more equal in my experience. One of the reasons why Python sort of floats to the top in those kind of charts or above Ruby is actually that Python is super useful if you are doing a lot of machine learning and specific like scientific libraries that exist for Python that aren't as popular in Ruby. But I mean, to answer your question, it's like poke around online, talk to people in the startup world. I mean, I'll list some that I think are in that sweet spot today, but it really has to do with going out there, seeing how active the community is. Do you know any startups who are using the thing that you're planning on, that you're talking about using? Or of the startups what are they using, and why? And I think if you just basically pull people who are in situations similar to yours, you'll see what's happening. And that's a little bit of a cop-out as an engineer, because it feels like sometimes that you want to say, well, why should I care what anyone else is using? I want to select the thing that is right for me. That's right, you should select the thing that is right for you. However, A, it's very probable that a lot of other people in your situation have similar needs, and therefore it's pretty close to what is right for you. But B, and what gets overlooked sometimes is, yes, you could pick the language that is, from a language and framework perspective, perfect for you, that might not be what other people are choosing, but there is immense value in that active community. And there's immense value in that active community because of all the libraries that are out there, because there's a huge support community of people helping each other and solve problems when problems come up, and because you're going to be able to hire people who know that framework, right? And it's like, so even if you say like, well, there's this new thing, and this new thing actually is super awesome, it does these 5 things, 10% better than that other language, so why wouldn't we select it? Sometimes the answer is, well, because there's just not enough of a community there yet. The way I would judge that community, talk to people in the community directly, understand what they're doing, and you can do that in person. You can just also do that online, see which communities are active. You can go look at, for Python and Ruby and Java and Scala and PHP and all these languages, just kind of go to some of the main sites that will show you the activity of like libraries that are being developed for those languages. Like for instance, for Python and Ruby, you just like look at the new gems, or you look at the new Python libraries that are being developed and how rapidly those are coming out, and get a sense of what they are. It's like, oh, they just incremented the new library, or there is a new library that matches this latest web service that just launched, or here's they're revving the Mongo library like every week, as opposed to you'll see other ones where it's like there hasn't been any activity on this thing in a year or something. Right? So some specifics. So obviously on mobile, seems somewhat obvious, but can get a little less obvious when we get beyond the basics. So for iOS, Objective-C is the natural thing to be developing in. iOS is less fragmented than Android in terms of the actual iOSs that are out there and supported and being used, which can be kind of nice. And we'll talk more about that. Android, obviously, you're working in a Java framework. Both of these, you have SDKs for iOS and Android that you'd be working with as well. But from a language perspective, that's kind of the default, right? So that piece is a little bit obvious. Having said that, then what comes up a lot is, okay, what about doing a hybrid app, where a hybrid app is trying to not have to code your entire mobile application twice or in two different languages for those two different platforms. And some of those are HTML5, JavaScript. A lot of them are actually HTML5, JavaScript, where you code in, you're basically coding in a web technology, and then it's kind of wrapping that in a native wrapper. PhoneGap is like that. Some of the other technologies that are out there that help you do that, or packages that are out there, sometimes use languages other than HTML5 and JavaScript, but that's certainly the most popular one. So that comes up a lot. I think what a lot of people, certainly my personal experience, as well as the experience of people that I've talked to, as well as the experience of some of the bigger companies, the Twitters, Facebooks, Dropboxes of the world, have found that trying to do that, even though it sounds awesome because you can develop most of the core functionality of your app once and then have it run on multiple platforms, the reality is there's a lot of performance penalties. That code is not at all optimized for the native platform. You start getting problems where some of the functionality that you're building doesn't fit the UI paradigm of that particular mobile OS, which can be problematic just from a UX perspective. In general, it's been, sort of much better in theory than it is in practice. The one that's come up recently, just very recently in some talks, that makes a little more sense to me and others, but probably only in the longer term, unless you have guys who are super into developing in C, is that you could do some C core libraries. So Dropbox does this, Mailbox app does this, and they've been talking about it recently, where instead of having an HTML5 JavaScript core that is cross-platform, they have core libraries in C that they've developed, which they use in all of their mobile apps, where those core libraries provide core functionality, but it doesn't include UI functionality, but includes, like in the case of Dropbox, it's all of the core API stuff that just has to do with syncing files and like moving files around and handling authentication and where things go. And so when they write that, they write it once. When they update that, they update it once. And then those C libraries are bound into their Java and Objective-C code within the iOS and Android apps. And I don't even know if Dropbox probably does have a Windows app or something that uses the same code. So if you're really into code reuse on the mobile front, that could be an interesting way to go. Having said that, that requires coding a bunch of core functionality in C, which is a much slower language to develop in than a higher level language, and you need people who are comfortable doing that. But could be useful in the longer term. Again, in the short term, not sure that that's super important.
One thing I also want to add is that a lot of us using Bluetooth, so with that, using HTML5 and stuff probably wouldn't work, and we'd have to stick with like Java and Objective-C.
Right. I mean, you could still potentially do like UI elements in HTML5, but then you'd still be doing the native work for the communication, the Bluetooth communication, et cetera, in the native language itself, right? So what percentage, I mean, even in the best case where you're not dealing with Bluetooth and so forth, you maybe could get like 80% of your functionality in HTML5 and 20% still going to be native, right? So it's questionable. The only situation in which I've actually seen kind of the HTML5 thing work well for anybody are instances where a company has already spent like a lot of time building out a web app first that was entirely a web app, where they've done all this work to already generate the HTML5 and JavaScript that does all these things, and then they made a mobile web version of that, and then they're able to take that mobile web version, package it up, and distribute it as a native app. And there's not, at that point, there's not a huge penalty, but there's also not a huge benefit, right? It's basically like you already had that experience by pointing people to that URL and getting that experience on the web, and sure, now you're wrapping what is essentially a mobile web experience and calling it a native app, which may give you some distribution advantages or other things that are slightly useful, but as a starting point for wanting to do a app on iOS or Android doesn't make a ton of sense. And so then the question that comes up a lot for folks is, do you do iOS first or Android first, assuming that you have limited resources? There's been a lot of talk around this recently. And folks are, in general, still doing iOS first, which is interesting because, so if you look at the numbers, these are recent numbers that I just pulled yesterday. The top numbers are August 2013 for US and for install base, versus a number that got a lot of press, actually literally just came out yesterday, where the numbers around global shipment. So if you look at global shipment market share, just like how many smartphones are being shipped today in the world with which OS, and it's like 81% Android, 13% iOS. It's like overwhelmingly Android, right? And so that number might make you think like, well, shoot, Android is the most important one. We should just deploy Android first. Having said that, yeah, you look at the US install base, 5241, which is not that different at this point in time. And then you combine the 5241 with what we touched on a little earlier, which is honestly, Android is harder to develop in, and Android's harder to develop in because you have all these different versions, not just of the OS, but devices that have kind of made customized versions of the OS, the Kindle Fires of the world, et cetera, and it's just a lot more fragmented, as well as some of the tools aren't as good. Yeah.
And then for us, I think one of the more important things is that with iOS, the customers that actually buy iOS devices will much more likely spend money on your hardware. So
Yep.
Hardware startups, that's what we care about. So
Yep. Oh, for sure. Yeah, and I didn't have as much hard numbers around that, but it's certainly kind of the early adopters in the US, whether for hardware or just in general, certainly, yeah, more affluent with iOS. And what I've seen is just, in the US, they tend to be the people who are like willing to embrace new faster as well, right? A lot of why Android is getting 81% globally has to do with just the cost of those devices, and you have a lot of low-cost Android devices going out into various places. But then you're right, it's like the people who are buying those low-cost Android devices aren't people that have a lot of disposable income for new, cool hardware devices, right? So, if I were in your shoes, I would tend to, if you were going to do one first, I would tend to do iOS, which is the choice that a lot of people are making, even though if you were to look at it just purely from the number perspective, it would suggest that Android would be the way to go, right? Backend services, assuming you're doing any, which not all of you may be doing so at this exact point in time, but even if you aren't right now, I think there's a lot of reasons why you might want to in the future. I'm not going to get into one language being better than another in sort of some religious way. I think there are a lot of good choices. As I mentioned, the green on this presentation are really ones that I've seen a lot of success with and have personal recommendations for. So when you think about backend for startups, the four that jump out to me are basically the Ruby Rails framework, the Python Django framework, Java and/or Scala, and some of the associated frameworks with that, and Node and some of the frameworks there. So, I've got some points around what some of the differences there are. I think, Ruby and Python have a lot of similar market position. People have preferences, of course, for one versus the other. But if you're thinking about using one versus the other, you can think of them fairly similarly. Yeah.
What's the difference between Ruby and Rails? I have no idea. Why is it that
Meaning, what is the difference between Ruby and Rails specifically? Or
For example, I see that you have everything in there, like PHP goes with Perl, right? Or like thing. Then Python goes with Django, and Ruby goes with Rails.
Yep.
What is it?
Sure. Yeah. So again, this is good because it helps me adjust kind of what level to talk about. Right. So Ruby is the language, and then Rails is a framework, and so and then Python is a language, Django is a framework, and then there are frameworks for there's all kinds of different frameworks for Java, and there's some Scala frameworks, and there are web frameworks for Node, etc. So Java is the language, Scala is the language, Python, Ruby. JavaScript in the case of Node.js. Node is adding a little framework itself there. So you start with the language, and then depending on what you want to do, we touched on the fact that in a lot of these languages that are in the sweet spot, people have already probably built things that help you do what you want to do. So whether or not you use like Rails, for instance, in the case of Ruby, Rails is this framework, and when I say framework, it's like instead of having a library that helps you do some specific thing, Rails is an entire framework that helps you build web applications, meaning there are libraries for certainly servicing web requests. There are libraries for how you build object relationship models between kind of the service itself and external data stores. There's a lot of infrastructure that makes it really easy to build, in the case of Rails, like a RESTful web service. Yeah.
Like for example, MFC. Sorry, like in old days, I don't know.
Yeah.
MFC is the framework.
Right. Exactly right.
So it's sort of like all these set of libraries and sort of like.
Right. And so it's just sort of like, these frameworks, you can just think of them as like kind of a heavy collection of libraries that are oriented towards building web services generally. When I talk about these frameworks, there are some other kinds of frameworks, but in these cases, towards web services. And so I'm actually interested in knowing this feedback from you guys, but there's a couple different things that I see being useful. So one is that you might need to build. One is if you're building a backend service that is just returning data to another device, and that device could be the mobile device, like a mobile app, a native app on iOS or Android, or it could be literally returning data to your hardware device if you have like a Wi-Fi connected device, or you're just passing data through a cell phone to your device. But basically, if all you're trying to do is like make a request and get back some data, like JSON data or XML data or whatever format you want that data in many cases these frameworks are overkill, right? So I mentioned under Node, that it's a good candidate for fast light API endpoints. But I'll talk about this in the context of Ruby also. Like, if all you were doing was building a service that's like, okay, I'm going to request some data, and it's going to return some JSON data about whatever current conditions are or something. My device gets the weather, and I just like request, what is the weather today? It comes back with an answer of what the weather is like in San Francisco, and it's just all in data. Doing something like Rails, doing something like Django, they're overkill. And there's not, I've seen people do that, and again, the downside to overkill, frankly, most of it does have to do with the efficiency and kind of slowness and performance elements that we talked about a little earlier, which aren't super important in the beginning. But if you're doing that, if all you're doing is like building an API that returns data as opposed to building a website that does presentation, a lot of these frameworks are overkill, and there are lighter weight frameworks. I didn't list some of them here. I can, so for Ruby, for instance, instead of Rails, there's something called Sinatra. Sinatra is oriented towards basically just returning data. It's just like request comes in, do what you want to do to go get that data, return it as data. Yeah.
Do these frameworks already include something for database stuff, or
they include connectors to the database, and in many cases they include an object relational mapper, which is like ways of abstracting the data that's in the database so that you don't need to deal with the underlying kind of communication mechanism of the database itself. So in the case of a SQL database, you could write raw SQL and get to the database, or you could use an ORM and kind of abstract it and think about it in an object-oriented way. So in most cases, these frameworks include those models, but they don't include the database itself. Yeah, you still select a database. So like in the case of Rails, you could select MySQL or Postgres or Mongo or whatever, which we'll talk about a little as well. Yeah.
What's your view, related to that, what's your view on using Docker as a service platforms for people in our stage looking for something rapid?
Yep.
Scale?
We will get to that shortly. So I have a section on that. Right, but so frameworks, yeah. So there's heavier weight ones. The heavier weight ones can be used to do lighter weight services, and there's some downside to that because they're just heavy and more complexity than you need. And frankly, it's pretty common that a lot of people will do something like build out an API service using Rails, even though there's like all this code then that you're loading and is kind of involved with the framework that you're using that you're not touching and you don't need. How much that matters, again, it's like, well, eventually it's going to matter. Eventually that's going to slow you down. It raises your cost per request. Like the memory requirements for, returning a small API request, but you're loading the whole Rails stack. It's like a little slow to load that stack. It requires a lot of RAM. That means you're doing less number of requests per server. That's going to cost you more, et cetera. Having said that, it's fast and easy, but so is Sinatra, and so is, Node. Node has a couple frameworks that are specifically oriented towards just returning API data quickly. Node also scales really well. These are all good choices, and it sort of depends on what you're building, what I would recommend. If you're building, again, a website that is just like, oh, you're going to be displaying pages and people are going to be clicking from page to page and showing, you're going to be showing a bunch of templatized data that involves a lot of presentation layer, then a lot of these frameworks are helping you handle that as well. Again, the ones in green are the ones that I consider to be sort of the sweet spot. Arguably, C# and Net could be there as well. It's just certainly in the Bay Area startup scene, Microsoft is not used that often. Doesn't have the open source appeal of a lot of others, even though there's nothing horribly wrong with it per se. Go I list because, as I mentioned, it's getting a lot of attention recently. It has some really nice concurrency features, but it's a little early to be in that sweet spot. And then PHP is sort of the opposite, which is PHP, was super popular, 10 years ago, and a lot less popular now. Though there's nothing wrong with it. You can crank out a website or an API endpoint in PHP. It's not like it's not going to work. And there's certainly a number of people out there who enjoy using it. It's just in general probably a little bit coming out of vogue and less activity in terms of how quickly people are writing new modules for it, et cetera. Data stores. So yeah, you asked whether or not Rails, contains a database. It does not, and none of those frameworks do. So you pick a data store separately from the framework, or if you could choose not to use a framework at all. But if you choose not to use a framework, you're going to go language. You're still going to select some libraries. So in this case, for instance, you would select like, okay, I'm going to use Ruby, and I'm going to pick a data store like Postgres, and then you, at a minimum, are going to use like libraries that help you access Postgres without having to directly figure out the Postgres protocol. And even more so than the things we've already talked about, like this is not where you want to use something bleeding edge. Again, unless you really, really need it, it's definitely fun to do bleeding edge. I enjoy bleeding edge in terms of like it's fun to play with new technologies, right? And certainly we've gotten a little more mature on things like the NoSQL data stores over the past few years, but it's still fairly early for some of them. Some of them are getting mature, and we'll talk about specifics in a second. But this is not. If there's anywhere that you want to be stable, it's your data store, right? You don't want bugs in your data store. You don't want things that end up corrupting your data. You don't want things that end up bringing your data store down, because those are the ones that are really, really impactful to your service. things that are kind of higher up on the chain, like your app servers and your caching servers and a bunch of other things, when they crash, not a huge deal. I mean, it's not great, but presumably we've architected the system in such a way that you have multiple of all of those things. The load balancers go around it. You reboot that server or restart that server while there's a bunch of other servers working. Data stores, much more complicated to do that. Yes, you can have master slave and the master went down and now the slave's taking over, but it's actually not, even in the best of the situations like that, it is somewhat disruptive and not something you really want to be dealing with. And that's in the best case. In many cases, you don't have the best case. In many cases, you have bad things happening if you have a data store that is unstable. And things, we can happy to answer questions of my view on some of those things, but that's just kind of like for specific technologies, but that's, kind of the overall way you should think about it. For instance, Mongo's been super popular around a certain startup set for a while, but had all kinds of problems early on, and we can debate whether or not it's kind of mature enough now, but folks who started using it, including kind of their most high-profile user of Mongo for a while was Foursquare, ran into all kinds of problems with it because frankly, it's just immature. Like lots of good ideas in it, awesome that you can do some auto-sharding stuff, but not the most stable thing in the world. Yeah.
The complexity point is it worth hiring an engineer who knows inner join and normalization and all those database words versus just trusting your programmer to handle it?
Depends on your situation, of course, right? I don't have a generalized answer for that. It's like when you get, the way I would think about it is one of two things. So it's either you know in advance that you're building something that is going to be highly like data store and data model dependent, and you're going to be doing some pretty large amounts of heavy lifting on the back end versus, you have a service where it's like, well, we're storing a bunch of user profiles and, whatever, small amount of data per user, probably doesn't require huge amounts of expertise. Versus if you're doing something that's either massive amounts of data or you're going to try and do like super complex analysis on that data because you're going to be doing like a lot of batch processing, machine learning on trying to sift through the data sets. In those kinds of cases, aside from the skill set that you would want for like, I need a machine learning guy or whatever, you tend to run into, we've got a lot of data to move around and interact with each other, and having somebody who actually understands kind of optimizing how to interact with the data store and how to move the data around, or in some cases, and this is becoming more and more common, not move the data around, but take the code to the data, becomes important. But really, it sort of depends on your particular case, of course. What else did I have here? Test. This is one of those things that nobody does at your stage. But I'm going to say it anyway, which is, obviously have backups. People do backups at your stage, but what they frequently don't do is actually test to make sure that their backups work. They just sort of implement backups and say, hey, look, it's backing up, and there's files going somewhere, and we're sending our files to S3 or whatever, and that's great until you actually need to restore and figure out that you don't know how to restore. And the same applies for lots of other elements in your system. So I mentioned Chaos Monkey here. Netflix wrote something called Chaos Monkey that's kind of cool. So particularly if you are in the cloud, but this applies even with physical hardware, it's like things are going to fail, right? And so you have a couple choices. You can either test how the system responds in those failures, intentionally by bringing things down and seeing what happens, or you can just wait for it to happen, and eventually it'll happen, and then you'll know. So what Chaos Monkey is Netflix wrote a thing that randomly kills servers and services within Netflix. You run it, and it just goes around killing stuff. And the system should just adapt, right? Wouldn't recommend, you guys don't need to spend the time to actually do that, but having that mindset of just anything can go away at any time, and using services like Amazon actually helps people get in that mind frame a little more, mostly just because that happens more on cloud services like Amazon than it would if you were running your own hardware. But that's actually good, because if you're running your own hardware, it's still going to happen. It just doesn't necessarily happen as frequently, and you tend not to think about it as a common use case that you need to plan for. Mostly this is pretty easy to deal with, actually, again, at the app server level and sort of everything but the data store level. The data store level is the hardest one, and if you don't choose a data store where someone else is handling that for you, if you're running your own data store, then again, it is important to understand the backup restore process as well as the failover process when a machine goes down. And then understand how to scale it, right? So on the data store side, again, I'll say there'll be a recurring theme here, but you don't need to do the scaling work now. So when we'll talk about sharding, you don't need to do the sharding now. You don't need to do the work in advance, but you do need to understand what the roadmap is so that you just have a good concept of, oh, well, here's what we're doing today, and this is going to see us to this point, and then when we scale beyond that point, here is how we're going to address it. Some popular ones, of course, no surprise, I'm sure, for you guys to see Postgres and MySQL on the list. There's like Oracle and Microsoft SQL Server and other SQL options out there. On the NoSQL front, there's a bunch of popular ones as well. The only one that I've personally highlighted in green is Hadoop and HBase, mostly because I've seen people run into a lot of problems with some of the others because they're fairly immature, right? So there's great feature sets associated with Mongo, with Cassandra, with React, with Couch. There's a lot of cool stuff you can do with them, but they're not necessarily that stable, which, again, stability in your data store are pretty important. Hadoop is quite stable. HBase has been quite stable for people. Having said that, no reason to use Hadoop and HBase unless you have data sets that require it. Like, there's complexity cost with trying to implement something like an HBase. HBase can scale really, really big. And that's awesome, and it can do that in a pretty reliable way. But it is complex to implement. It's not just like, oh, I'll just stand up an HBase server, and it's like not that simple. But if you're working with super large data sets that aren't going to be easily managed by SQL servers, you can do that. How about no? Okay. We can talk more about that if you want, and we will talk a little bit about some use cases around Postgres, for instance, which would also apply to MySQL and how to scale it out. So then, aside from your persistent data store in your main database, there's caching layers and some things that are kind of in between where you could use them as caching layers or semi-persistent data stores. Memcache and Redis being super popular for those approaches. As I mentioned at the bottom, Redis and Memcache are both super reliable. They're really stable, super fast, and therefore super useful. I would highly recommend incorporating one or both into what you do, primarily at a minimum for caching, but there are more advanced use cases beyond caching where, for instance, if you're building out a timeline system where people are loading timelines, you can actually assemble those timelines in something like a Redis and not necessarily be hitting the database for those. And you can either persist some of the data that's in Redis to disk, or in many cases, you can not bother to persist that data to disk, but you have data going into your permanent persistent data store, like in MySQL or Postgres, that could be used to rebuild the data that is in Redis, if you lose your Redis instances, which just means it's slower at that point. You're using it basically as a cache, but it's a slightly more complex version of a cache where it's not just that you're reading something out of the database and then storing it in the cache. It's that you're primarily using Redis as the place that you're reading and writing from, but there's a separate stream of data that's being written to a permanent data store that could be used to rebuild what is in Redis if necessary. But Memcache is just sort of a no-brainer also. There are libraries that will manage some of that for you if you're using frameworks, like we mentioned, Rails. There are caching components to many of those frameworks that you could just say, I want to use Memcache as the backend for the caching strategy that the framework itself implements, or if you're doing a little more, close to the metal, just implement your own caching. And we'll talk a little bit more in the performance section around how you might use some of that. Infrastructure is where someone asked about, platform as a service, infrastructure as a service, software as a service, et cetera. So everything as a service. And yes, at your size, at your stage, there are a lot of potential upsides to using some of these things. There are costs with using them, but it lets you not worry about a lot of things, right? But there are trade-offs associated with that, so we'll go through each of those. Infrastructure as a service, which is really just, when we talk about Amazon EC2 and Rackspace Cloud, which we were mentioning earlier, Microsoft has Azure, there are a bunch of other ones out there, but those are some of the more popular ones. Joyent has them also, and I've seen good success on that. Basically, all of you will probably use this level if you're building a backend service at all, just because the concept of buying and or leasing your own physical hardware and then taking care of that just doesn't make any sense anymore unless you're so huge that you need the efficiencies that come with that, right? Like if you're Google, if you're Facebook, whatever, then sure, you're designing your own servers and dealing with that stuff. But you aren't, and there's literally no reason to do that. It is cheaper, you can make an argument that it would be cheaper to run your own hardware, but there's no, it's again, as we covered earlier, the amount of cost associated with that is probably so low compared to the rest of your business that it is unlikely to be meaningful at this point, right? If you guys have a number of employees that are causing a burn rate, of X, your server costs are unless you're doing something super crazy with your service, are going to be so low that it doesn't matter that you're paying a little extra for somebody to manage all these things. Plus, you'd have to be paying, of course, the salaries of folks to manage those. So EC2 itself, obviously the market leader for cloud services, for infrastructure as a service. It's been, it's good in that it is well recognized, well supported. Again, everybody has libraries that kind of deal with it well. The downside is the performance has been pretty variable. It's not been the most reliable thing in the world. It's not the most predictable performance in the world. But it's, it's a good choice. It's pretty solid. Joyent I like a lot personally. Certainly not as well known as Amazon EC2. They have much better I/O performance. You can get to support easier. AWS tends to be very opaque about what's going on with the system when things do go wrong. Joyent also happens to have experts in Node. But there's a bunch of other good choices here, like Rackspace Cloud, fine. I know people who use it, have good experiences there. Just find one that works for you. There's a number of good choices. I'm just picking my favorites here. Yeah.
So if you chose to use one of these services, do they also host the databases? And if they do, they provide backup services as well, or not?
Yep. So those are the different layers. So many of them do. So I'm just talking about them at the different layers. So at the infrastructure as a service layer, we're just talking about basically, okay, now we're not running our own servers. Now they're running servers for us, but you're still responsible for all the software, including the databases, app servers, everything else. Then we move to software as a service. So software as a service, yeah. So in the case of Amazon, there's S3, which a lot of you may have heard of, that is a data storage service that Amazon provides for kind of static data, or is best used for static assets and large assets. But they also have RDS, and RDS is MySQL as a service, right? So if you want to use MySQL, you could use RDS. They will basically run MySQL for you. There's also entirely different kinds of databases. S3 is one where it's an object store. Joyent has a version that's sort of similar to S3 called Manta, where it's an object store, but you can also run code on the data that's in the object store without having to move the code, which is pretty cool. DynamoDB, so Amazon Web Services has their own NoSQL database as a service, right? So rather than running a NoSQL database that you have to manage, Amazon has one that they basically invented called DynamoDB. Google has the Google Cloud Data Store, sort of similar concepts where they're basically key value stores that they scale, they keep reliable. You don't need to worry about it. And those, it means reliability and scaling aren't your problem. However, having said all that, there is a lot of loss of control and loss of insight into what's going on there. Can be good early, on, but I've worked with a lot of companies who have gotten frustrated with those over time because they get a bunch of performance variability and a lot of opaqueness around what's going on, right? Suddenly it will get slow and there's just not much you can do about it. Like, just the service is slow. You can complain to your service provider and they may get back to you and acknowledge that it's slow and that they're working on it, right? Or it may not be just that it gets slow for a period of time, but it may be that just sporadically throughout the day, individual requests take a long time, right? It's like your average request is being returned in 50 milliseconds, but then 1 out of 100 requests is taking 5 seconds or something, and just some frustrating things like that. Depending on who you're dealing with, security concerns can also be an issue. So there are people, for instance, who do MongoDB as a service. I've listed Mongo Lab here, which, disclosure, I have some interest in because Freestyle Capital has an investment there. But there's a different one called Mongo HQ, I think it was, that just a few days ago got hacked and had a big data breach. So people who were using that service, they had to go and contact their customers and let them know that some of their data may have been breached, right? Which is not good, obviously, for anybody involved in that, including Mongo HQ or their customers. So then it's like, how do you think about those risks? Because sure, people will talk about that as being a downside, and it is a potential downside. If you turn over your data to software as a service and they don't keep it secure, then obviously that was a very bad decision. Having said that, if you keep your own data and you run your own data store, you need to keep it secure. And unless you are employing people who are quite good at security, it's debatable whether or not you are going to be able to keep it more secure than the other guys. I think, in general, obviously, larger, more established companies, as much as I hate to be that guy who says, like, don't use the little guy, what we have seen more recently is the little guys have been more susceptible to being hacked. And the reason for that is the same reason that you might be susceptible to being hacked, which is honestly, they don't have the resources to be employing a bunch of security guys to be on the job all the time, which is a little unfortunate. But if you think about like a DynamoDB, a Google Cloud database, et cetera, does Google probably have pretty good security around their cloud database? Probably. Or do they probably have smarter and more dedicated security engineers working on trying to keep it secure than you do in your tiny company? Probably. There's no guarantee, and so to a certain extent, it feels bad if you put your data somewhere and then they get hacked. Of course, it feels just as bad, or maybe worse, if you put it in your own databases and it gets hacked. So that's a little on security. We talked about performance. Cost also. For all of these layers, you're going to pay more cost. Again, for me, I do think at your stage with the volume that you guys are likely talking about, that cost is not consequential compared to the salary costs and everything else that you guys have that are actually making up the majority of your cost structure. But again, that really depends on your particular company. But I think that's going to be true for most of you guys. Data export issues also, most of them support that, but when you think about a strategy of saying, okay, well, we'll use them for now, and then we'll move off to something else, just make sure that you understand what is possible in terms of extracting your data from the system. They all will let you get your data out of the system some way, but if you accumulate a large amount of data within their system, make sure you understand, like, how are you going to extract that data to put it somewhere else, and what kind of a time frame is that going to take? Like, it might literally take weeks to pull your data out to put it somewhere else, just because of the amount of data involved and how quickly you can retrieve it from the system, depending on how much data you've built up in there. Yeah.
We have a product that we have a map device that you want a way to actuate it when it's on your back, remote control.
Mm-hmm.
And so that's an important feature. The other part of that is there's a lot of data with the sensors that we have on the device visually. It's not a device, I think, that we can kind of launch it alone without the
Sure, without a back-end system. Yep.
But I'd really like to have that data early on so I can analyze these
Mm-hmm.
information for the design later on and just make a case to other investors like this is what we've seen so far and this is the value to be credit.
Sure.
How feasible it is for every one having, a good deal of challenges ahead of us with making this reliable hardware as well as, the app is trivial compared to the hardware. But there's enough issues in order to start up. Should we overextend ourselves to kind of get that data involved early on? Is it, how complicated is it to build an infrastructure? We have, cloud interface, the app that's sending this information to the cloud.
Sure. So you already, just to make sure I understand the situation, you already have an app.
So we have a demo app that we're building. It's just like a remote, few knobs, very basic.
Yep.
Few pages, and then you have the device, and we're kind of getting good progress there. But see, they're a company that called us up and they said, hey, we're, these are incubators, and we do like the web infrastructure for, these cloud connected devices. And we do it at no cost, and we charge you later on. So I don't know what that means.
Sure.
I'm sure it's not.
Right. I'm sure they have a business model that works for them, but yeah.
So the question is, if I'm sitting here and I want to have that data and kind of understand my company better in the long term, as well as like case investors, should I be rushing to get that versus focusing on this core functionality? It's a big question, but
Right. And I feel like we can take it offline a little bit, because some of it to me depends on what specifics of your business are and what the business drivers are and how important that data is. But the one thing I will say is, if you already are building an app, is that like an iOS? Right, so an iOS app. If you already have your data going to the iOS app from the sensors in the device, not hard, one thing to think about is, definitely not hard to start sending that data to something on the back end. And that at least starts giving you the ability to do even just manual analytics on the back end to kind of look at how people are using your service and what's going on. So to me, like, the amount of effort involved in doing kind of a really basic way of getting it up there that isn't yet really providing a service based on the data, but is letting you get a lot of insight into how people are using your device, worth it and should be pretty easy. Whether or not you go with the guys who are giving you like the free thing, there are a lot of things that are practically free at this point, right? You could use Amazon instead of those guys, and like for the amount of data that you're initially collecting, like it's probably going to be like, oh, this month your Amazon bill was $25 or something, like whatever, depending on volume, right? But it.
the devices, the managing of that is just it's automated, right? You have all that manual later on. Analyze that.
Right. Right. No, I think it's a good model, is just like start dumping that data up to the cloud, and even if you have basically nothing on the back end that's doing anything with it other than you are manually going in and looking at it and running some queries against it, I think that it's a super good model. You can always build those out later.
Will you send your email to go?
Yeah. My email is in the prezo, and I believe the prezo is going to be emailed to everybody. Platform as a service is yet the next level up from software as a service. So this a few years ago didn't really even exist as a level. First we saw kind of replacing the server level. Then we saw people starting to offer software as a service, like replacing the database layer or offering data stores as a service. And now we see entire platforms as a service. And what that means is, like we talked about Rails earlier, Heroku is a service that lets you run, for instance, a Ruby on Rails app on their service, including them providing the data store, including them scaling out the application servers that are running, your Ruby on Rails service. Google App Engine does that for Python and Java and I think a couple other languages now. There's a bunch of other ones, OpenShift, Flynn. There's one that just got announced by Yandex in Russia called Cocaine, which I had to list because that allows you to say, maybe we should consider using cocaine. So, kind of like that. But in general, so it's like, should you consider using one of these? I mean, it's just a step higher up that chain than we were talking about, and therefore the considerations are actually kind of similar, except intensified, right? Extremely easy to deploy and maintain the web services. You don't need to worry about, like, we talked about not needing to worry about like physical hardware, but you still kind of had to worry about how many virtual boxes you were accumulating, and you had to administer them and make sure they weren't being hacked into and so forth. In these cases, like, you don't need to worry about any of that stuff. Like, you don't even need to worry about really how many servers you have. You just kind of say generally how much performance you want, or have it auto-scale to certain limits. Yeah, so it's super appealing for people who are really early stage. Again, the flip side's black box. It just kind of magically works, but it magically works until it doesn't. And when that is and where that is a little hard to predict. Meaning sometimes that's you get so big that you hit limits that were unclear in terms of how you could scale for them. And a lot of these platform as a service companies are understandably targeting the lower end, kind of the folks who do have smaller requirements, because those are the ones that don't want to or cannot spend the manpower to build it up themselves and deal with these things. Because of that, they tend to not have a ton of huge customers. If you become one of their bigger customers, in many cases, you can start running into issues where it's like, oh, well, our database was magically scaling until we hit a point where it turns out now we've hit like their largest level of database scaling, and they just don't have anything more for us. So you just can't get bigger. At which point you need to move off of that system. So in my opinion, it is definitely, I've seen it be really helpful. I think it can take a lot of worry off of your plate as far as like dealing with any of this stuff. Just understand the cost, right? You're making a decision that is going to only get you so far, and I don't think there's anything wrong with that. It's just you need to plan for, okay, if we do achieve product market fit and things start taking off, we probably need to start thinking about moving off of that system at some point. And that doesn't mean, again, suddenly jumping from like using a platform as a service all the way down to now we're going to run our own hardware or something. Way before that, it's probably like, okay, we were running a Ruby on Rails service on Heroku. Now we're going to take that Ruby on Rails service and we're going to run it, directly on Amazon. Heroku has been using Amazon to back their servers, but you could sort of take one step down. But there are costs with that, right? I mean, that's a project that your engineers would have to do to make that transition. So it's really, it's a short-term benefit, short to mid-term benefit that you will have to pay for later. But that doesn't mean you shouldn't do it. It can help you get to market faster. It can help you take your very limited resources and focus on, the things that are unique to what you're trying to do. So I'm actually, even though I'm talking a lot about some of the downsides, I'm actually a pretty big fan for people who aren't, particularly actually in the case of folks doing devices. I think, if you aren't that familiar with doing these things, which is part of why I'm giving this talk, is that we assume some of you are not, like it's a good way to just postpone having to deal with it. And that postponement will let you work on other things like product market fit and getting your device done, and dealing with all the other stuff that Highway 1 is going to help you with relative to supply chain and et cetera, right? So I in general, I'm a fan for certain situations. You just need to keep in mind it's not going to be a magic answer forever. And even in the short term, you may run into some things that are frustrating relative to the black boxness of it, right? It might get slow, it might go down, it might have some issues where you're not sure what is going on, and you're going to reach out to support, and support's going to write you some very generic response that doesn't give you a lot of insight probably, and then it'll eventually get fixed. But yeah, I think it can make sense. Scaling. We talked about horizontal scaling. Again, that is important to plan for. You don't need to be throwing a ton of boxes at it initially, obviously, but you need to plan for how you can. and where it makes sense to implement the horizontal scalability, not throwing the boxes at it, but making sure that you're in a position to be able to throw boxes at it up front, you should. There will be a cost to doing that for certain things like the data store that can also be postponed as long as you have a roadmap to doing that. And so that's where I want to talk about kind of a progression that I've seen work for a number of companies, and one in particular recently that is a high growth mobile app where they have a iOS app and an Android app that was doing okay for a while and then started taking off, right? So initially they did what most of you would do unless you're using platform as a service, but you can think of that in sort of a similar way. But they had one data store, right? So in this case they had Postgres. So it was the data store that they chose. So they've got one Postgres database. It's not just running on one server because they have master slave in case the master went down, but that doesn't give you a lot in terms of performance and scalability. It's just like we have a pair of servers. It's still one database. Everything is there. As you need more capacity, you can make that database server bigger, right? I think when I first started working with them, that database server was like, I don't know, an 8 gig of RAM, 2 processor server or something. Not that they owned the physical hardware, but that's what the virtual machine was on Joyent where they were running. So for a while, they could continue. As the service started to grow, it was just like, oh, well, let's go from an 8 gig machine to a 32 gig machine, a 64 gig machine. And by the time they get to a 64 gig machine, they were starting to hit limits for the particular service that they were using. There are other virtual, there machines and cloud services where you can get machines up to about 256 gigs, but once you hit 256 gigs of RAM and probably 32 processors or somewhere in that range, you will run out of vertical scaling capability within a given database machine. And yeah, I mean that has to be dealt with. You can't just keep buying a bigger and bigger database machine, and that is the one where people typically don't have horizontal scaling built in from day one because, frankly, it takes work. So what do you do about it, and in what order? People will talk about sharding the database, and sharding the database is like a shorthand way of talking about something, but it's also kind of a broad way of talking about something. So your goal, if you're in one of these high growth situations, or even linear growth that's still getting you to maxing out these servers, is, as always, you don't necessarily need to do more work than is necessary at any given point in time. So at the first, as you start seeing that coming, and preferably before you're actually maxing out your machine, you think about what the next step is. So a next logical step, rather than do the work that is somewhat complicated to do true table-based sharding, or whatever your data store calls a table, but basically a collection of information of a certain type. Before you actually start spreading that information across multiple servers, the more obvious and frankly easier thing to do is you can take individual tables and move them out into different databases, right? So if you had like a users table and user activity table or whatever it happens to be, you can just take one of them and move it into a different database. That different database goes onto a different server, adds some complexity to your app servers or whatever is accessing the database, because now they need to know about these two databases. But that's not a big deal for a little while. It's like, okay, which database do I use for this table? I use that one. It does mean one of the things you need to do in order to plan for that, and I'm a big fan of recommending this up front, is don't do a bunch of database joins. You may have heard of this already, but database joins both tend to cause performance problems, but they also get in the way of getting into horizontal scalability, right? And when I say database joins, I mean joins that are being done between tables by the database itself, as opposed to, sure, there are reasons why you may need to intersect data from one table with data from another table, but the more you can think about doing that at a layer up from the data store, meaning typically at the application server level, so what I would call an application server join, the better, right? So if you needed to go look up a certain user and find their name, and then you needed to go look up, the past 10 activities they had in this user activity table. You could do that all at once and cause the database to bring both of those things back and map those together and do that join. Or you could write your application server logic so that first you go and get the user profile based on, maybe you're looking that up based on email. So you look up that based on email, but there's a user ID associated with it. You get the user ID back. Now that you have the user ID at your application server level, then the application server issues a query to the other database. But even if it were still at the point where you had one database, then you issue another query to go pull back the user activity associated with that user ID. And you do that separately. And when you talk about that, that sounds slower and it sounds less efficient than doing it as all one thing where the database is doing it for you. And that is true. It is slower and it is less efficient. But it's not so much slower that it's going to make a big difference, assuming you have modern, fast, databases that are not overwhelmed. You're probably adding a couple more milliseconds to this, and if it's then sending it back to a mobile device or something, your latencies are so high that a couple milliseconds are not going to be noticed. And as you start having to do more and more of that, you can say, well, that's going to add up over time, and that can be true. But in many instances, you'll be able to do some of those queries in parallel, and some of those things will not add up in a sequential fashion. You can start merging them in from parallelization. Is this making sense to you guys, by the way? Cool. So as you do that, then the next thing to think about. So anyway, in order to enable that, I guess I'm just saying, don't do database joins, right? Where you can avoid them, do them at the application layer, even if it seems like, well, this is a little slower, because assuming you plan on growth to the point where you're going to have to split your database up, it's going to save you a lot of time later in terms of unwinding all of those joins. Not that you can't unwind those joins. Again, I've seen a lot of companies do it. It's just it becomes a big project of going through and unwinding the joins, breaking them out into the application server level, in addition to actually breaking up the database. But the vertical table sharding that I was talking about, so what we call vertical sharding is really just taking different tables, moving them into different databases which live on different servers. That can buy you a fair amount of time and some amount of scaling. It's only going to last so long before what's going to happen is one of those tables. So in my example, the user activity table, that table itself is going to get so big, so hot, so utilized that it is going to start overwhelming whatever your reasonable maximum size for a single database is going to be. So vertical table sharding is not going to work. So next thing that happens along that path, I would say typically, but it's really more like what I recommend and what was true in the case study that I'm talking about, is rather than just go into a mode of saying, okay, now let's start horizontally sharding that table, we start talking about services-oriented architecture, and that's a whole, I could talk about that for a while and won't because we're going to run out of time soon. But as you think about splitting pieces of your data in your database and moving it onto more and more servers, for a number of reasons, including this kind of code manageability as well as just coherence around how you start thinking about building out, how you start horizontally sharding these tables, building a service on top of that makes a ton of sense. So in the case of this user activity table that we were talking about, rather than just say, okay, now the user activity table itself is going to be split across 5 databases, and now the application server logic needs to know that, and you configure, you have a sharding key when you do that kind of sharding, and it's like, okay, well, based on user ID 12345, I know that user 12345 is going to be on database server number 3, and that's where I go get it. All of that logic, if you start building that into your main application, is just going to make everything super convoluted. So one of the reasons, or one of the ways to get around that is you build a service. That service is a separate web service, or web is the wrong thing, but it's a service, a software service that sits there and responds to requests for information from the user activity, what used to be the user activity table and is now the user activity service. So you just build, something. It doesn't have to be the same technology that you use for your main API or web service, but it could be. But you could just do something like build a little Node.js service or a Ruby Sinatra service or whatever. And that service, what it does is it takes a request, and the request is give me the user activity for user 1, 2, 3, 4, 5, and then that service knows, okay, now I go and figure out that user 1, 2, 3, 4, 5 currently lives on database number 3. I will go retrieve that data and then return it to the application server. But the application server doesn't need to know anything about that. And in fact, so the reason why I have it listed here before horizontal sharding of the services database is because you could take the user activity table, still one table, build a service in front of it. That service initially doesn't need to do any of that work around which database it lies in. It simply gets the request. It knows that all of the user activity is in one table. It goes and gets it. But the key is then when you do the horizontal sharding of that table, there's no impact at all to the application server because the application server is still just making the same request it's always made to the user activity service. The user activity service is returning the same thing it's always returned. It's just the logic in that service has changed to be able to go find it on a different shard on a different database. So I could talk about that for a long time, but won't. Caching, we talked about this a little bit relative to Memcache and Redis. Do a lot of caching, do write through when you can. One thing that I see people do a lot, which doesn't make a ton of sense, is first request comes in for a piece of data. That request goes and hits the database. You pull that, like the actual data store. As you're retrieving the data, you put it in the cache, so now that data is cached. Next request comes in for that same piece of data, and you check the cache first and see if it's there. And if it's there, then it's cache hit. That's great. But in many cases, the data itself that you're looking for is being written. There are other requests coming in that are generating the data, that are writing that data to the database. And in many cases, people just write that data directly to the database, and then the request comes in for that data. It looks for it in the cache first. It gets a cache miss. It gets it out of the database, puts it in the cache, and then the next one hits it. But the first request could be a cache hit also, but what you need to do is actually write that data to the cache when you're doing the write to the database. Yeah.
Just one question. In the kind of situation where you have a device that's talking to a mobile phone, it's going to post that to a web service.
Yep.
Does it ever make sense to cache on the phone? Like on mobile device?
Sort of, yeah. I'm thinking of it in a slightly different way than caching, but relevant question because, there's different, for you guys, I think there are different paths that some of you are using, right? Some of you go device to mobile to backend, some go device PC backend, some just, if you have a Wi-Fi enabled device, you might be going direct from the device to a backend. But so the way I was thinking about that is more for the failure cases and sort of buffering reasons, but the caching definitely makes sense as well because of, not wanting them to have to wait. Having said that, it depends on how you have things architected. You don't necessarily need to have that cache in order for them not to wait, right? The key is to architect things so that you have asynchronous communication and your app is still responsive while in the background it's doing things, right? So like if you look at something like Instagram or whatever, Instagram does a really good job of, you say, post this thing, and it's like, great, I've posted it, but it hasn't actually posted it yet. It's just telling you it's posted it, and in the meantime, you see the little spinner actually, is still trying to communicate and upload that to the back end. But in the case when you have a device, absolutely using that mobile layer as a cache or a buffer, both will give you the performance improvement, but also it allows for the case where basically you don't have any network connectivity, right? So it's not just a fail case. It's like, okay, well, you'll get it there, and then just make sure that you're implementing retry logic in the app itself. So when the app isn't able to get it to the back end, it can just retry at regular intervals. One thing I will mention there, by the way, though, is once you get to a significant number of devices, be careful about that. Have exponentially increasing backup logic in terms of how often you're retrying, because otherwise you will just overwhelm your servers. What's going to happen is you have some number of servers that are receiving these requests from the mobile app. the mobile app is smart about buffering it up and then is retrying. But if you have it like retrying every 5 seconds or something, and then your servers go down for an hour, when you bring them back up, all of your mobile apps are simultaneously trying to post all of this data that they've saved up, and guess what? Your servers are going to go down again. So the recommendation there that has been a pattern that lots of people have used that works well is you get a failure case. 5 seconds later, you try it again. Then you go 10 seconds, 20 seconds, 40 seconds, 80 seconds, et cetera, and just keep doubling. So that you're not pounding the crap out of your servers that are down for some reason. Also, there's things like network link conditioner on the iOS side, although you can use it to apply to other conditions. It's part of Xcode, where you can simulate bad network. And again, this is one of those things that a lot of people gloss over, but you really should experience. You don't want the first time that you see what your app does under poor network conditions to be out in the wild. You want to see that during the development cycle, and there's tools that let you simulate that. Development process, agile with lowercase a, as I would describe it. If you're not already familiar with agile development processes, probably should get familiar with them. Some of them apply more than to larger teams rather than smaller, right? When you just have a couple guys sitting in a room, some of the stuff isn't that relevant. But as you grow, more and more will be relevant. But the things I think that are obvious even when you're really small to do early are just how to prioritize backlog of user stories, which are really just a prioritized backlog of tasks that you want to get done. Stand-ups aren't really necessary if there's just like a couple of you sitting in a room. You're constantly in communication. But once you get past that point, having daily stand-ups, which are just meetings to everyone talk about what they're working on, whether they're blocked on anything, what they got done, what they're working on today. And then the concept of sprints. I think sprints are super helpful as a concept even fairly early on, which is just like instead of just every day coming in and doing as much as you can, define a time frame in which you want to measure what you get done. That could be a week, 2 weeks, whatever. Just pick some period of time. And even for small teams, even 2 or 3 people, you can start to look at what did we get done this sprint, what do we get done next one, and that doesn't mean you need to release code at the end of every sprint. It just means that you kind of have a defined period of time. You see how much you got through. You talk about that as a whole. It gives you a chance to do what I mention next, which is you can have a retrospective at the end of the sprint where you look back and just say like, hey, what did we do right? What did we do wrong? How'd it go? How can we improve? And then plan the next sprint as well. And those don't need to, again, if you have a handful of people in a room, it doesn't need to be super formal. As you get bigger, will become a little more formal and just a little more organized. Project tracking, I'm not going to spend a lot of time on. There's good tools out there. Pivotal Tracker is obviously one of the more popular ones. Source control, Git and GitHub are kind of the thing to use. Technically there are other choices, and for a while, years ago, there were people using SVN. There were people, potentially using Mercurial or other choices, but really Git and GitHub have won that war, and just makes sense to use.
What about like a private alternative? GitHub makes it all public, right? Oh.
Yeah, you don't need to make it public. So you can have private repos on GitHub, and many people do. DRY, if you're not familiar with it, is now I'm going to forget the acronym. Don't repeat yourself. Yes, exactly. And avoid wheel reinventions, even from here. What I would say is like, don't repeat others also. So don't repeat yourself. If you write something once, keep reusing it. Also, though, as we talked about, tons of libraries out there that have already done a lot of things. Some of them might not be great. So I mean, if it's a version 0.1 of some library, and you could do it better yourself, then great, do it better yourself. But if there's something that's a really well thought out, really well implemented library that's out there that does what you're looking at doing, look for it first, right? Don't just always write it yourself. I know we're running into noon here, so I will try and wrap this up quickly. Quality, unit tests, and continuous integration. If you're not familiar with those, get familiar with them. Highly useful. I'm not really talking about test-driven development here. You can make a choice as to whether you want to be test-driven development or not. What is important in either direction, whether you're writing code first and then writing tests, or writing tests first and then writing code, is that you have the tests, right? That's the bigger issue here, is just make sure that you have high coverage in terms of unit testing. Behavioral testing, you could do, I like Jasmine for JavaScript. There's a bunch of other tools out there. You can do some mobile testing also. Again, early on, you guys just playing with it is probably good, but as it gets more complex, as your app gets more complex and as you're making changes to it, it might be nice to have automated testing of that. And there are frameworks out there that help do that will let you define specific flows of people interacting with your mobile interface, and telling it what the expected result is, and it'll automatically run those tests and see if they passed. User testing, that's a whole different ball of wax that we could talk about for a while. Also, one thing that I was thinking about relative to the hardware case is, what I have seen a lot of companies do is you can, if you just had an app, like a mobile app or something, there's great services out there that you can just say, great, I'd like 100 different people to use my mobile app, and here's the flow I want to go through, and then you get to watch them do it and see how people are interacting with your app, and you learn a lot from that. Obviously, in the case where you have a device involved, is a little harder to do that. You can't just have them using the app without the device unless you have a way of handling that. But in-person user testing, obviously, you can bring people in here to get that done. Controlling change feature flags, if you're not familiar with that concept, is the concept of when you build a new feature, having a flag that turns it on or off for any particular user. Again, super early in your development, probably don't need to do that, but once you've got something out there that has significant traction, super helpful thing to do. So Twitter and everybody else do things where you turn on a feature for like 1% of your population first and see how it does, and both see how it does in terms of performance, like if it's causing you any problems, are there bugs with the feature itself, or is it causing unnecessary system load or unexpected behaviors, as well as you can actually start to use it for doing A/B testing in a mobile environment, which is not something that happens a lot today, but it's starting to happen more and more, where you can start turning on behaviors and turning off behaviors after the fact. So you could actually turn on a behavior for 50% of your audience, and then actually measure how it works for that 50% versus the other 50% who's got better engagement, retention, whatever it is that are your drivers. DevOps, lots of stuff around DevOps. I know we're running late on time, so I'm going to skip over some of this, but in the prezo itself, I think I've called out a bunch of tools there that are helpful on that front. Instrumentation, someone brought this up earlier, so instrumentation and metrics. This is another area where people tend to not do enough. They tend to overlook things. There's obviously instrumenting things is not directly building features, so it feels like slightly unproductive to be working on instrumentation instead of building out features. Luckily, there are a lot of services now that make it easier to do. Mixpanel is a super popular one. Flurry certainly super popular for mobile. Mixpanel, though, I will call out specifically just because you basically can send any event you want into Mixpanel, whether that's from your mobile app or from your server side, or anything that you can communicate to the back end. And they make it pretty easy to just whatever you want to track, just put an event into that, into your device, into the mobile app, into the back end, whatever. Send it into Mixpanel, and then Mixpanel is going to give you pretty graphs and trends and alerts and whatever based on that data. New Relic also, depending on the language you use, but New Relic supports a lot of languages now. Pretty much most of the ones that I highlighted as the sweet spot, New Relic will support, and New Relic gives you a lot of insight into the performance of your application, where time is being spent, all the efficiency stuff that we talked about before that, again, isn't super high priority initially, but you can, if you're having things that are slow, and causing user impact because they're slow, that's a whole different situation versus efficiency and optimizing for cost. And New Relic is going to help you identify those pain points, whether there's like a super slow database query so that then when you're trying to do something on the app, it's taking forever, or if it's something in the code itself is taking a long time. There's a bunch of apps that I talk about that are good for doing actual monitoring, charting out the graphs as well as doing the alerting, and then PagerDuty, presumably once you have a service that is out there in the world, you guys are going to have a small team, but you're going to have people who expect your service to be up and running all the time. PagerDuty is just a good one that has risen to kind of the top of mind relative to who should be alerted. It's like, okay, one of your engineers should be alerted, or you have a rotation of engineers who should be alerted. And then if they don't respond, it should alert the next person. It's just good for setting that stuff up, because the reality is you're going to instrument all this stuff, but unless you're constantly watching it, it's not that helpful. Something needs to tell you when things go wrong. One other thing I will say about Mixpanel, though, and the type of events to instrument is don't just instrument technical things like, or user actions per se, but you can instrument things that are of business value, right? I mean, certainly signups, but also, if people are whatever, upgrading, or I don't know, depending on your particular business, what those things are, but you can be looking at Mixpanel for kind of technical data, but also be looking at it for here are the business metrics we're super interested in to know if you're doing well. As well as, sort of one level down from that is like, well, which areas of the product are getting the most use? What are people liking? Yeah. Yeah.
How much effort should you put into anonymizing the data that's coming in? Like, for like the metrics coming in from my device, it's like if I want to store all of the user's history, there's some privacy concerns around that. Like, should I be able to pull up any user and know, this is user A using the device, or?
Right. The typical answer is whatever you are comfortable asking your users to give you permission for, right? So it really depends on the type of thing. If it's like you have a wearable, that is recording movement data and that sort of thing, it depends. What do you want to tell people about that? I think in many cases, in order to display for them their own data, like if you want to create a web service and then they go to that web service and it's like, oh, here's a chart of all your movement and whatever, you have to store it non-anonymized. Like they log in and you want to show them their data, right? And the bigger thing is like, are you going to share that data with anybody outside of your service? And if so, that is likely to be anonymized. But there could be, other cases that are business specific. But the anonymization really just depends on your use case. But in many cases, you really actually need to tie it to user identity. Obviously, need to make sure that you're super careful with the PII, and the personally identifiable information, and that we come back to the discussions I was having around security and so forth. Like, you do not want to be in the position of sending out an email to your customers telling them that, the data that you collected is now fallen into the hands of some third party that stole it. So, encryption of that stuff rather than anonymization, I would certainly suggest as well. In the case, again, depending on what kind of data you have, but if I'm thinking about a use case of just user data associated with a wearable or something, it's like, if I were you, I would, first of all, it's like you're just going to have a user ID or something, so try and keep that abstract. Try to encrypt actual PII, so even things like email address you can keep encrypted on the database side, but you're able to decrypt that. But what you want, even though if somebody were to get in and get to your code and get to the database, they can probably decrypt it. But what you're looking to prevent is when sort of a more straightforward attack, somebody gets in there and like downloads your database. The question is your database full of plain text information that is personally identifiable, or are those pieces encrypted and they have to find the encryption key somewhere? And in the case where you don't need to know about it. Again, like the case I was describing where you want to show them a chart, one of the questions you need to ask yourself also is, do you need to see that chart on your business side, or is it only necessary to see it for an authenticated user, in which case you might be able to, have them have the key, and you don't necessarily have the key. The problem with that in real world scenarios is going to be something like, well, you want it to work on multiple devices. How are you going to get the key from one device to another? And if they lose the key, how do you actually get to it again? So convenience tends to outweigh that particular kind of security in most cases. I'm going to mostly skip hiring. You guys can look at it when we send the slides around since we're running late here. And I will just go to, and this is also because I think someone else is going to talk to you about hiring. Q&A on things we haven't covered to the extent you guys have time. Quietness. I assume that means you were asking your questions during the pre-sale, which is cool. Good. Awesome. All right. That was me. Hope you enjoyed that. Hope it was somewhat helpful. Thanks, guys.